the next topic area, which is domain modeling. And essentially, the big thing we're going to be looking at here is the kind of the data side of things, not so much the process side, and how you'd start thinking about modeling what the data how the data should be stored for the system based on the requirements that you've gathered and the use cases that you've created. So let me share my screen. There. Don't know why I'm having so many problems today. All right. Okay, so when we talk about domain modeling, the big thing that we're thinking about here is, or as the textbook calls it, are things. And things are really kind of a colloquial way of saying data. And of course, we would restrict this to the scope of the system. You know, what exactly should the system be storing? The text defines it as items that users work with when accomplishing tasks that need to be remembered. They give some examples like products, sales, shippers, customers, invoices, payments. As you can tell, really what it boils down to, I mean, I really feel like the text is being almost intentionally obtuse with the way they are describing this. I mean, to me, it's a lot of words around saying, this is stuff I want to store data about. And when you see things like products and sales and shippers and customers, it's pretty clear that that's what he means. These, like, what types of products do I have? I want to store a record for like a surfboard or wax or t-shirts, or maybe a surf company might have these types of products that they're selling. And this is where, again, I diverge from the text a little. I'm going to cover the text and what they talk about, but I do think there's some pretty significant problems with the way he talks about it. And that's this fourth bullet point, where he kind of gives two options for how you would model these things. One as a domain class or as a data entity. Perhaps. I mean, yes, that actually is a true statement. But there are very specific contexts in which you would choose to do domain classes or choose to do data entities. And the author seems to think that they're interchangeable and you use whatever you'd like. This last point here, it says in the text, the author calls them domain classes, and from a database perspective, you'd call them entities. I actually modified this a little bit, and I think the original version is still on the Course Scholar site. So if you're following along, you might notice this bullet point's a little bit different. I believe it's originally said something like, in this class, we'll call them, the CPSC 350, in this class, we'll call them domain classes, and in a database class, you call them entities. And I changed that because, I don't want it to speak for me. First of all, we're not going to do that. We are going to do it from a database perspective, because that's the case 99.9% of the time in industry. You store your data in databases almost all of the time. And there's a very specific context and time and place for when you would use domain classes. They're not interchangeable the way in which the author states as a fact. And it's unfortunate, but I don't think he actually understands that these are distinct things. There's a reason why we have two different things. And I'm going to get into that a little bit. Before I do, let me double check. Okay, good. Just making sure that I'm recording. Okay, so that's an important thing. And, when I pull test questions, one of the reasons why I'm covering this is that, I want to make sure that you guys, if you're studying from the text, that you understand the types of things I'm going to be asking. The things that are wrong, that I'm going to address that are wrong, I'm obviously not going to ask you questions on a test from that wrong perspective. I'm going to ask you things from the correct perspective, and I'll make note of that as I go along. All right, this is great here. So this, let's go back to say what he did right, what the author did right, and these two techniques that he describes for identifying what the things are actually pretty commonly used techniques, and they're pretty effective as well. The first technique he talks about is the brainstorming technique, and this is where you kind of have this. It's almost like a standardized list that has usual things that you store. For example, almost all organizations are going to have some type of employee group. So that would be one of the things you would look at in brainstorming. Almost all of them would have customers and products. You might call them something different. For example, in a university setting, the people that are being serviced are not really customers, they're more students. But it's the same type of interaction that they would have with the system that a customer might have in a more retail-oriented organization. And then there's the noun technique. I would say between these two, from what I've seen anecdotally, the noun technique would be a more common approach than the brainstorming technique. The problem with using standards is that not only is every organization unique and different, but every situation and every sub-process and sub-unit within each organization is also pretty unique. So when you're using standards, oftentimes you're going to be looking for things that aren't appropriate, and you're going to miss things that are appropriate because the standards don't think about that very specific and unique situation. With all of that said, I have seen the brainstorming technique done, and it worked relatively well, but it was probably more the exception to the rule than the norm, which would be the noun technique. The reason why the noun technique is more used and more common is because it builds directly on the work that you did during requirements gathering, where you're thinking about all of these things. You have all of these interview notes. You're starting to model out the sub-processes and the actors involved. And when you have all of this information, to simply look through all of that and look at all of the nouns is a pretty straightforward process. As we'll get into later, there are some pitfalls to it, but those generally are overcome with experience. People, as they start to learn how to identify proper nouns, ones that really should be entities, or as the author calls them, domain classes, it tends to smooth out, and it is an iterative process. So let's start with the brainstorming technique. Again, you have these kind of standardized lists of things, such as tangible things or roles, organizational units, devices, sites, locations, and then this last one, incidents, events, or interactions. These are quite important because they can be overlooked. Thinking of your guys' project, for example, one event that is probably central and most important to the entire sub-process that this is within the organization would be assigning committees or assigning people to committees. So that's not a tangible thing or a role or a unit or anything, but it is an event that is really the reason why that system should exist. So you have these kind of broad categories, and then you start applying them directly to the system in place. And it's generally pretty comprehensive, but as I said, you'd be surprised the types of unique things you run into in different organizations, as well as different contextual situations within organizations that you can miss out a little bit with this brainstorming technique. And all the information that you're hopefully getting from this, you're cross-checking with the existing data that you've pulled from your requirements gathering and the initial modeling you've done during the requirements gathering. So here's the discrete steps that the text lays out for the brainstorming technique. You'd identify a user and a set of use cases. So Clearly, that's been done by this point. You have your use cases and actors already determined. Brainstorm with the user to identify the things involved when carrying out the use case. So you see, with this brainstorming technique, you're taking a step back into additional requirements gathering, which isn't necessarily a bad thing, except for that it can be time consuming. You've already done a whole set of interviews up to this point. Now you have to go back and do additional interviews to talk to them about, okay, we've identified this use case as something that you do. Tell us everything about it. What are the things involved when you're doing this thing? And it does talk about some systematic approaches, in terms of following up with questions when you're talking to the user. Specifically, are there tangible things that you store information about? Are there locations? Are there roles? So these categories that the last slide identified, that they're kind of the starting point for these follow-up questions that you would do with the users. And you'd have to do it with all of the actors, users, stakeholders, to really expand this list and get more and more things that might be domain classes or entities. This step 5 is interesting, and this is where you're trying to figure out, okay, so I have these things that look similar. Do I bring them together? Do I just eliminate the other one? And you're kind of sorting out what the final solution is. All right, so then there's the noun technique, and this is the one that is definitely used more commonly. It says at the very beginning, you have these discussions and documents, and from that, this is kind of your requirements gathering that I talked about before. From that, you're going to systematically go through and just pull out all of the nouns, all of the things that describe a thing, something. The author correctly points out that this is popular. This is something that is done quite a bit. And it's possible, this third point says that you could end up with very long lists and nouns that are things that don't need to be stored by the system. That's definitely a possibility, and I would say the newer the systems analyst is, the more likely you will be to have that type of situation. People with more experience tend to do it pretty well early on and don't have this problem as bad. You're always going to have to whittle it down. You're never going to have a perfect list right off the bat, but you definitely need to consider that you early on, in your career, if you ended up doing something like this, that it's going to be a long process after you've identified the nouns. Difficulty identifying synonyms and things that are attributes. In other words, synonyms are just, okay, I have these two things that different people described with different words, but they're actually talking about the same thing, and sometimes that can be tough to figure out. And then the last one is extremely important, and that's confusing entities / domain classes with attributes. And if you're not familiar, an attribute is essentially a field within an entity / domain class. So, for example, entity / domain class might be student. Student name is an attribute for that entity. And sometimes you've identified a name, which is a noun. A name is a noun, and it might come up and initially be considered as a domain class in and of itself. And sometimes that can get confusing, so it takes a lot of iterative work going through and saying, oh, no, this is actually part of this, and this doesn't stand alone, and wait, this thing that I thought was part of this does stand alone, and that type of situation occurs. A good place to start when there are no users available to help brainstorm. That's a very loaded sentence right there. The implication, what I'm inferring from what the author is saying here, is that this is an inferior approach, and you could start with it if you just don't have any users and you're essentially a loser yourself. I mean, it's a very pejorative sentence in my opinion, and I don't think it's appropriate, because it's not that there's necessarily no users available. It's making the most efficient use of your time as a systems analyst. And one of the, as you saw in the last test, there's a test question about this. One of the most time consuming things is this requirements gathering in terms of all the interviews you have to do. If we're talking about 200 or 300 interviews, it could theoretically be months of work to collect all of that. And to say I'm going to do all of that, and then I'm going to start thinking about modeling it, but in order to model it, I'm going to go back and interview more, to me is I don't think that's necessarily a goal. I don't think that's something you should strive for. Whether or not there's users available is besides the point. I think it's a good place to start because it's systematic and it does the job at least as well as brainstorming. So I kind of reject that last point there. I think there's too much inference going on. All right, so what are the steps for the noun technique? Using the use cases, actors, and other information about the system, including inputs and outputs, identify all the nouns. In other words, I have all of this data that I've collected from my requirements gathering, and I'm going to go through it piece by piece, line by line, and I'm going to identify all of the nouns that come out of that. They give the case of this running case in the textbook, the Rocky Mountain Outfitters. And they say some nouns that you might have include customer, product item, sale confirmation, transaction, shipping, bank, change requests, so on and so forth. So there's all these things that they pulled out from this analysis that they've done for Rocky Mountain Outfitters. Using other information from existing systems, current procedures, and current reports or forms, add items or categories of information needed. So what this essentially is saying is you're going to expand on the types of things that you would store based on the nouns that you have. So you might even go above and beyond what you have here. As this list of nouns builds, you would refine it. And kind of similar to the brainstorming where you have, confusing attributes with entities, and the redundancies where you have multiple things talking about the same thing. You're kind of doing the same thing here for step 3. So you would ask questions like, is this a unique thing? Is it in the scope of the system I'm working on? Does the system need to remember more than one of these items? Ask these questions to decide to exclude it. So I'm going to exclude it if, for example, I've determined that, well, this is a synonym. It's the same thing as something else that I've already identified as a noun prior. This one's actually pretty important. Is it just an output of the system produced from other information? So this is actually, I would say, an extremely important point because oftentimes you create, not oftentimes, I would say as a primary purpose of information systems, you create information from data. And the classic example of this is, say I have a table full of orders. Say there's millions of records in it. There's millions of records in this table that I have for all the orders that the system has placed, or that customers have placed in the system. So this data is, in and of itself, not valuable to humans because, if I have millions of records, I can't really make sense of it. It's just too much for my human mind to really wrap my head around. So what I want to do is turn that data into information. And the classic way of doing that is by creating a report. So I have millions of records for orders, and then I might want a report that says, okay, this is the total number of sales for the quarter. This is broken down by demographics, broken down by products. This is the trend line. It went up, it went down, it's flat. This types of information I could fit on a page or 2 or 3, and now it is consumable by me, the human. Now, what I'm doing is I'm creating things, if you will. Remember, we're looking for things here that don't exist in the system. For example, the trend line that shows up, down, or flat. The total product sales grouped by demographics, total product sales grouped by product. These are things that, they're things, but at the same time, even though it's very valuable, I don't want to store that because I'm pulling that from the existing data. So this point here that says, is it really just an output of the system, is an excellent point, because that's the point of the system, is to create this valuable output. But at the same time, I don't want to store it. Not only is it pointless and redundant to store it, it could actually be dangerous, because now with this redundancy problem, if I am continuing to change things in my raw data, I'm also then going to have to go and change it in this other thing that I'm storing that would normally be produced from that data, and I have to have additional processes to do that, which could lead to potentially errors and conflicts. So this is an extremely important point here. Is it really just an output of the system, or is it the actual data that I want to store? And the same thing for input. This is the other side of the IPO equation: input, process, and output. So moving on, this is still part of step 3 in the noun technique. So the types of questions I would ask to research it: is it likely to be a specific piece of information, i.e. an attribute or a field, about something that I've identified? Is it something I might need if assumptions change? So again, this is all part of the refining process for identifying my entities / domain classes. Create a master list of all nouns identified, and then note whether each one should be included, excluded, or researched further, and review it with users, stakeholders. So even with this process, you still kind of have to involve these providers of the data that you got during the requirements gathering. But the difference between this and the brainstorming is the brainstorming uses their information as input directly into identifying nouns, whereas this one uses it as verification. So you're saying, okay, this is all the stuff I've identified, and I'm just kind of verifying it with them to make sure they're on board. So you're not completely not interacting with the users, but it's a much smaller scale than you would with the brainstorming technique. And so here we have some slides that, again, continuing with this Rocky Mountain Outfitters, they've done whatever technique where they've identified the nouns and they've made some notes about that noun. So with accounting, they made a note saying, we know who they are, there's no need to store it. Back orders are wondering, is this a special type of order? In other words, would I have a separate class / entity for back order, or do I just have, is back order really an attribute within order that's just a special type of order? So these are the types of things they're thinking about. We have some more here. Color to me is pretty clearly an attribute about a product. So, but it is what it is. They've identified color as one. Credit card information, is this part of an order, part of a customer information? Again, this one's usually part of customer information, but it depends. Oftentimes, customers are not comfortable with having their credit card stored by various organizations, so they say, don't store this information. So generally, what happens then is that it's not stored at all. So it's pretty rare for it to be kept as part of the order as well. Anyway, these are things that you would think about. So again, the author really focuses on this domain class thing, and it's a little bit problematic. So these are some things that he's identified as details about the domain class: attributes, keys, and compound attributes. Now, you could replace the word or the term or phrase domain class with the word entity, and these would all be exactly the same. Entities also have attributes, keys, and potentially compound attributes. So use in this case, use them interchangeably. And again, I will be getting to the actual mistakes and errors that he has about that in a little bit. But for right now, just use those terms interchangeably. So what is an attribute? It's essentially a field. So if I have a table and I'm storing information, I'm going to have fields within that table to classify that information. And they give the example here of a customer would have first name, last name, phone number. These are examples of attributes for customer. They might also have addresses, or even in a compound attribute example, they have the address. Instead of being one block, it would have subfields or sub attributes for number, street, city, state, zip. This is actually quite helpful for reporting if I wanted to say, how many people ordered from this zip code, and it would be a lot more difficult to do that if I had that as one block of text. For all of the attributes, you have to have one that uniquely identifies an instance of the class / entity. Now, it does say that it makes some distinction here that for this key, with entities, it's required, you have to have it, and it's optional for domain classes. That is true. But if you choose not to use a key for a domain class, you're asking for big trouble because you would have no way to identify individual instances of, or rows in the table, essentially, is what I mean by instances of data. You wouldn't be able to reliably pull data from the class if you choose not to use a key. So I would say effectively they're required for both. Practically, or technically they're not, but effectively they are required, these keys. So a class is a type of thing, and an object is an instance of that class. To replace the terminology with the database terminology, you could say an entity is a type of thing, and a tuple is a specific instance of the entity. And a tuple is just a fancy word for a row, or an instantiation, an instance. It's that thing come to life. To give you an analogy here, you could say that a class or an entity is like a blueprint for a house. It just describes the house. Now, if I'm a builder and I'm starting to build models of what's represented in that blueprint, each house that I've actually physically built is an instance of the blueprint. And there could be, or almost certainly will be, variations. Even though it's the same blueprint, there will be variations to all these. Say I build 100 houses based on the blueprint. Each house is going to have a different color. They're going to have a different door style. They're going to have a different front to it. Probably have different windows depending on how much the customer wants to pay. So on and so forth. So these are kind of the attributes that are described in the blueprints, and then as they're applied, each physical house is an instance of that blueprint. And so when we talk about the values that are stored for the attributes, these are the instances of the class or entity. And here we have the example of customers, where we have customer ID, first name, last name, home phone, and work phone. This is straight out of the text, and I really, really hate it. I don't like it at all. What I don't like is that it's, to me, weird and not normal that they are putting the attributes in a column and then the values in a row for the individual attribute. That's not normal, whether you're talking about classes or entities. The way it normally goes is you put the attributes in a row, and then you put the corresponding values in the column under it. In other words, this should say 101, 102, 103, John, Mary, Bill, going down in columns here. It's not wrong necessarily, but it's just odd that they showed it in this way. I guess they're trying to show you the example of what the values might look like, but I don't know, very odd choice here. Okay, so, hold on, let me jump back here for a second. And let me ask, so far, are there questions before we jump into associations. Do you guys understand what a class is? What an entity is? What an attribute is? Do you understand the problem that I have with the text so far? Okay, well, I haven't actually said specifically the problem yet, but let me throw it out there. The problem that I have. Okay, actually, let me ask you guys first. I want to throw a question out to you. You can respond via chat box or speak up, turn your mic on. Can anybody tell me what an object is? From a programming perspective, what is an object? Or a class? As distinct from a function. It's okay if you don't know. I'm honestly okay with that. But I know, I think all of you, I think you've all taken at least the Python class and maybe 250 or maybe just Java. I'm actually not sure. I can't remember off the top of my head. Elijah says an object is an item passed into a function. Not quite. So a function will take data, which is distinct from an object. So you can pass data to a function. So let me give you, I think I mentioned this before. An object, yes, that is, Sean, that is technically correct. An object is an instance of a class. That is definitely true, which they've kind of addressed a little bit in these slides. There we go, Jack. Yes, that's the key thing I'm looking for. So Jack says an object is an item that holds data and functions in memory. Totally true, yes. And this is important because normally programming that's not object-oriented programming is just looking at the functions. And as Elijah mentioned, you can pass things to a function, which would be the data. And they're treated almost separately when you're doing what's called function-oriented programming. When we talk about object-oriented programming, as Jack mentions, there are data and functions together. They're seen as things that are part of the same thing. And when the author talks about classes, domain classes, and objects being instances of those classes, if you look at UML, if you've done outside of the textbook, if you do any research on Unified Modeling Language, which is what this is based on, there actually is a specific reference to function, and you have a separate area, and within your model for the domain class, you have what the name of the domain class is, what the attributes are, and what the function is. So you have all of these things, and the author doesn't go into that at all. He treats them the same as an entity where you only have the name of the entity and the attributes. And to me, that's where the big problem is, because they don't really they don't make the proper distinction. So in other words, or not in other words, but the big so what? Why are we talking about this? Why do we have UML and domain class modeling? When do you think you would want to use objects and classes instead of entities and functions? In terms of a design perspective here. We're not talking about programming anymore, we're talking about design. So when I'm designing things, when might I want to use objects and classes as opposed to entities and functions? I'll give you a clue. The answer does have something to do with programming. But again, I'm asking about a design process. Why would I choose to do one or the other? And this is, the author totally misses this. So as I read the chapter, I was just like, what are you doing here? I was almost getting mad reading it, because I was like, you're totally missing why. Essentially what he says is they're interchangeable things, domain class modeling and entity relationship diagrams, that they're interchangeable things. But in this class, we're going to use this. And in a database class, you're going to use the other thing. That's the extent of his description of it. And I said to myself, okay, first of all, it's unusual to use this. And when you do use it, is in a very specific context and case, which the author doesn't go into at all. I get it that you guys might not know it off the top of your head. I was hoping I could give you enough clues. But the time that you use it, the time that you would use domain class modeling, is when you know that the technology that you're using to implement it is object oriented. And that should kind of make sense. Well, if I'm programming in an object-oriented environment, I should be designing objects and classes so that I can immediately turn that into the code that needs to happen. And he doesn't say that at all. All he says is that they're pretty much the same thing, but we're going to use this in this class. No, they're not. And that's really why I jumped out of the slide right now to come back to you guys and tell you that I'm not going to be describing it in that way. And in industry, it is a very, very small percentage that go down that path. The majority of development that's done is with entities and functions. Objects have their place, and there are specific places in which they work very well, but in typical information systems, they don't work well, and entities and functions do. So, all right, let's jump back into it. All right, I'm gonna present, screen share. All right. Okay, so we've talked about identifying the things and thinking about them being these broader groups called entities or classes. Now, the important part is to consider the relationships, or as the text refers to them from the domain class perspective, associations between classes / entities. And these are, so far we've been talking about the nouns. These are essentially the verbs. So you would say an order is placed by, so that's the verb, Mr. Smith. Or Mr. Smith works in the accounting department. Again, the verb is the link or the association or the relationship between these groups of data. So this goes into a little bit more detail. Just the terminology is what he's distinguishing here. So in UML, with class diagrams, you call them associations. In database, you would call them relationships. They mean the same thing, and they do the same thing. And again, this is just a difference in terminology. The type of relationship / association would be called multiplicity in UML and is called cardinality in entity relationship diagrams. You have two choices in either one of these, which would be a one-to-one type of relationship or a one-to-many type of relationship. There are times when you will end up with a many-to-many type of relationship, but those are not acceptable to move forward, and you have to fix them. And the slides kind of go into it. I'm going to bump out of the slides and do an example from an ERD perspective to show you an approach of how to fix it. This also is pretty important. This last point here, it says they apply in two directions. So when you're building these and thinking about the relationships, you read them each way. For example, you might have an entity for students and an entity for classes, and you would say, okay, a student can take how many classes? And you'd say, well, they can take a lot of classes, so that would be a many side. And you say, well, a class can be taken by how many students? Well, by many students, so that's also a many side. So in that example, you're ended up with many to many, and you'd have to fix it. One more common would be, okay, I have customers and orders. A customer can place how many orders? Well, they can place many orders, but a single order is placed by one customer. So that would be a one-to-many type of relationship for that one. So that one would be good to go. Within UML, there is a minimum and maximum multiplicity that you would have to determine. For example, with a customer and order, is it possible to have a customer that hasn't placed any orders yet? And in most cases, that would be, yeah, that's possible. You have maybe a customer that's registered, and they just haven't bought anything yet. So that in that case, the minimum would be 0. Or you could say you can't become a customer until you buy something, depending on the company and what their requirements are. If that's the case, then the minimum would be at least 1. And they have some examples here. Mr. Jones has placed no order yet, but there might be many placed over time, and that's a 0 or more optional relationship. Particular orders placed with Mr. Smith, there can't be an order without stating who the customer is. This is one and only one, a mandatory relationship. And then finally, we have an order contains at least 1 item, but could contain many items. And this is the many side to it. So, moving on, types of associations: binary, unary, ternary, and n-ary. By far the most common type of association relationship is the binary association. And this is where you have relationships between 2 classes / entities. And here we have the example of a course including a student, members joining a club. That's by far the most common, like upper 90s%. Unary, this is where the relationship is to itself. For example, if I have a class or an entity that is all people, and then I have a relationship for marriage, well, there's not going to be a separate grouping for people. So, in other words, a person is married to a person, so the relationship would loop back to itself. Those, I would say, are probably the second most common, are the unary relationships. Within organizations, the most common would be like a supervisory type of relationship. So you'd have a single table for your employees, and if an employee supervises another employee, again, it's a relationship to itself. That's one that I've seen relatively commonly on the unary side. Much less common, as a matter of fact, in the real world, I've never actually seen them. I've only ever seen it in textbooks and classroom examples, are the ternary and n-ary relationship associations. So this is where you have 3 entities that are all related to each other. Now, what I mean by this is, let me hold on a minute. I tried something just a minute ago. Change layout. Here we go. I'm not sure. Oh, here we go. Can you guys see this? The whiteboard I just popped up? Or do you still just see me? I'm honestly not sure what you see right now. I've never done this before.
I still just see Professor Lapke.
Just me? Okay. So I think I'll just share my screen again, and then maybe there's something else I'm supposed to do. So I'd assume you probably see it now, right? Yeah, okay. All right. So let's see here. No. There. Well, that's rather unfortunate. Okay, I'm gonna have to do this the hard way. All right. That's supposed to be a rectangle, by the way. It looks more like it's like Connecticut, but it's supposed to be a rectangle. Okay. So if I have relationships that look like this, This is not a ternary relationship. So I want to make sure you understand that it doesn't just mean that there's three entities that are linked together by itself, because these are technically, or it appears to be three entities that are linked together. What this actually is one binary relationship right here, and a second binary relationship right here. This is not a ternary relationship. This is two binary relationships. So if this were truly a ternary relationship, it would look like this. Where now you have these three entities that are all tied together and interdependent on each other. Now, what this means is that, in a normal binary relationship, like these two, you would need to identify, okay, let's say this one is the customer, and this one is the order, and this one is the product. So the first thing you do is determine the cardinality. So you would say a customer can place many orders, and a single order is placed by one customer. So I would draw out the cardinality for that. So this would be an order is placed by one customer, and a customer, this is the crow's foot approach here. So a customer can place many orders. A product can be a part of many orders, and a single order can only contain one product. So here we have another one-to-many relationship. So in this case, you would say, okay, because this is the one side, this is required, this is the many side, this is the one that's dependent on that. So I would have one of my attributes here would be customer ID, which would be a key. The PK stands for primary key. And down here in order, since it is dependent on the customer, you can't have an order by itself is what that means. I can't just have an order that doesn't have any customer associated with it. I would have to have a foreign key or an FK pointing back to that customer. And you'd say the same thing for product, where you would have a product ID, and I would need to have that as a foreign key down in the order. And the order also, of course, needs its own identifying key. So in this case, I might just have order ID like that. Now, when I have a ternary type of relationship, making the determination is a little trickier, but you still could say one is reliant on the other, therefore that one would have that foreign key, and then all of them involved would have to have primary keys as well. So, all right, let's close that and do this. So back to ERDs. He briefly addresses ERDs. These are the entity relationship diagrams. These are kind of like the equivalent to the class diagrams. The term for things in ERD models is data entities. Most of the time, I've actually seen them just called entities, not data entities. They're not UML models, and they don't use standard UML notation. That's true. If generalization and specialization is something you need to do, I suppose UML would be better. But again, that's more the exception than the rule. They do not model the whole and part well. I don't agree with that. They model the whole and part just fine. And so we'll come back to that. All right. So you saw me do some of this with the little ERD that I created for customer and order, where you have the one side being indicated by the single slash, and then the many side with the crow's feet. If there is an optional relationship there, like a customer may not have any orders, you can also put that circle in front of the crow's foot to indicate zero or many. But you have to have exactly one customer if you have the one side going over with the slash there for customer. So you saw all of this in the example that I gave. And that zero side can go also on the one. If you say that it's optional. And you could also have one or more that's mandatory on the many side. This is a pretty similar example to what we saw before, where you had the customer, the order, and the order item. I noticed the author, I don't know if he intentionally or just forgot to include foreign keys, but you would have these, the entities on the many side would also include the foreign key. So in other words, for an order, I have to know what customer did it. What's the point to a relational database without linking customers to an order? Or on the other side, they also have order items. You would need to have an order foreign key for the order item as well. But nonetheless, he didn't include them there. So for an example here, we see customer, account, branch, and transaction. I think these are pretty self-explanatory. What are the key fields? Well, the ones that say PK next to them: customer number, account ID, branch, and so on and so forth. How many accounts can a customer have? Actually, let me ask you guys, can anybody answer that? How many accounts can a customer have? So you see a link between customer and account, one to many. Any guesses? Yeah. So he sees the one or many, so one or many. How many branches can a customer be assigned to? It's a trickier question. So let's look at the branch over here, which is linked to the account, which is linked to the customer. So a branch can have many accounts, but an account can only have one branch. So if a customer can have many accounts, theoretically, they could be a part of many branches, because you might have accounts that are assigned to different branches. Interesting setup. How many customers can a... Seems like the same question. How many branches can a customer be assigned to? How many customers can a branch have? Well, let's look at it from just that perspective. How many customers can a branch have? Well, a branch can have many accounts, and a customer can have many accounts, so it appeared to be many as well. So odd questioning here. I will not be asking you questions like that on the test, because that is kind of pointless to me. All right, the domain model class diagram. So we have a class. Its classification used to describe a collection of objects. A domain class that describe objects in the problem domain. A class diagram that shows classes with attributes and associations. I will grant it that he does mention methods, which is another way to say function. If it models software classes, fine. That's included there at least. But he doesn't really go into it anywhere else. Domain model class diagram. This is like the ERD. So moving on. The notation is pretty simple. You have your class name and attributes. Class name is always capitalized. Attribute names are not capitalized. And he suggests running the words together with the second name capitalized. Just a standard. There's no real reason to it. And we see the cardinality. Well, I guess they don't call it cardinality here. They call it associations, where it's a similar type of thing. So an order is placed by one customer. A customer can place 0 or many orders. And then same thing with the order item. Order item refers to one order, but an order can have many order items in it. One or many order items in it. And the notation, this is kind of, breaks it down in a similar way as the crow's foot notation. 0 or 1, one and only one, 0 or more, 0 or more optional, and then 1 or more mandatory. And we see the same bank situation here. The differences between this and the ERD are so minimal. I guess I'm not really getting it. The cardinality is done differently. Instead of crow's foot, you have the numbers. Slight differences in the way you write out the attributes and identify the key. You don't put PK, you put bracket key next to it. It's very similar. And here we see another example of this would be for course and course section and student. All right, so this is important. So I talked about the problem of the many-to-many relationships. And actually, I guess the previous slide didn't notice this, but the previous slide shows a many-to-many right here where you see a student can be a part of many course sections, and a course section can have many students. And in UML, the way you fix this is with something called an association class. I know what they're saying here. I'm not a huge fan of it because it still implies that the relationship is still there between course section and student, and it's not an allowable type of relationship. You cannot have many-to-many relationships. And the text doesn't go into it, so I wanted to show you again. Let's see. I'm going to pull up the whiteboard. I think we're slowing down Google here. All right, so I'm gonna have my top-notch drawing skills here. So we would have student and course section, which I guess I can draw it really quick. And I won't be using UML, I'll be using ERD. We have a many-to-many relationship here. A student can be assigned to many course sections, and a course section can have many students, and that's not allowable. You can't do that. And so at the association class, you see they have this kind of bump out with the dash connection here. What you do in the ERD, which is different, is that you remove this relationship, because as I said, it's not allowed, and you create what's called a linking entity. Now what you call it sometimes isn't clear. Sometimes you just use a combination of the entities that it's linking together. Other times, when you think about it, things that make sense come up. For example, a student in a course section essentially is registered for registration. In this case, there's one that kind of does make sense. So this did not say, for example, this did not come up for some reason during my initial analysis. All I had was these two with a link between them, which now I'm saying, there's something else here. So what happens is you now have this linking entity that you've created out of nothing that now says a student can register many times, but a single registration refers only to one student, and a course section can be part of many registrations, but a single registration is only referring to one course section. And so now I've replaced a many-to-many relationship with two one-to-many relationships, which is essentially what they're talking about here with the association class. Same type of thing. And the only thing I don't like about it, and this is splitting hairs, I mean, there's nothing wrong with it, but I just don't like that it implies that there's still this relationship here, because these are not allowed relationships. Here they're making some distinctions. Association class is the same, quote, thing. And remember, thing is what you're storing information about as the association itself. True. Again, very loaded sentence here. By putting quotes around thing, there's a lot of unsaid things here. Thing could be a colloquial term, meaning I'm just referring to this thing as something, or it could mean something like, okay, this is data that I'm storing, and the fact that they put the quotes around the word thing is indicating that it's the latter. This is data that I'm storing, but since you generally don't store data about the association, calling it the same, inferring that it's data, and calling it an association, it's odd, and it's, like I said, a very loaded kind of sentence that I'm unsure exactly what they're saying there. I think what they're saying is they're replacing the association with a data store, which is effectively what you're doing, but it's just kind of a weird way to word it. The key for the association class is the concatenation of the keys of the attached classes. Very good point, actually. That is a very good point, which I didn't really address here. So this one would have a student ID, for example, for its key. This one might have course section ID. So down here in the registration, its key would be the combination of the student ID and the course section ID. You wouldn't just come up with the registration ID here. That would not be a correct way to do it. And usually there's some third composite key here. For example, let's say one of you doesn't pass 350. You might take it again. Excuse me. You might take 350 again, but the database wouldn't let you take it again if it only had your name and the course section. So you'd also need a third composite key here for maybe the term ID or something. That's also quite common to see with these linking tables or association classes, as they put it. But yeah, this isn't definitely true. You do, at the very least, use the concatenation of the keys of the attached classes. That's true. Some more questions. It's the same type of thing we did with the ERD. How many bands can a person play in? One. We see one and only one here for a band. How many concerts can it play in? 0 to many. For a concert, how many bands can be playing? One or many. What attributes can you use for keys? Do they need to add key attributes? Let's take a look here. For the band member, name, years in band, and instrument. None of those would be good for a key because you might have people with the same name. You might have people with the same number of years in the band and people that play the same instrument. So yeah, you would need to add a key attribute for the band member. For the band, ideally you would add one, but I would say you could probably realistically get away with making the band name the key because I don't think you probably are allowed to have the same band name. So it's pretty likely that would be okay for that. For the concert, in this case, I would suggest not having just a concert ID. I would say having a date and location would be sufficient. Using these together as a composite key for this because Not likely you'd have multiple bands playing at the same time. Again, depends on the business requirements. If that is the case that you can, then you probably want to have a separate concert ID. And here we see another example of the booking class where you had this additional association ID sticking out. Okay. Let's X out of that, X out of that. Stop sharing. So we talked about domain modeling, and we'll be working on a hands-on thing with that next week. So were there any questions about it? For now. You might next week, but for now. Okay. All right. Well, thanks for coming, those that were here. I have to make an announcement about participation affecting grades because we're missing about a third of the class, so that's going to be a problem for some of them. But unless there's any other questions, I will see you all. Sorry, I was just checking the chat. I will see you all next Tuesday. Yep. Thank you guys. See you later.
Thank you.
Have a good weekend.
You too. Bye bye.